Hey kiddies. Alright, today we're going to be looking at the decomposition of sodium bicarbonate. So sodium bicarbonate, also known as baking soda, you've probably seen it before, a white crystalline powder, ionic compound. We're going to undergo a decomposition by heating this to turn it into sodium carbonate. And we're going to look at the mass change in this reaction and report that as a percent mass change and figure out how far we are away from what it should be by calculating a percent error. So let's get started. So the first part of this lab asks us to mass and record a evaporating dish. So the evaporating dish is a little dish, looks something like this. It's ceramic, handles heat real well. You have to gently heat it so it doesn't crack, but once you do that, it's pretty well able to withstand heat. So I'm going to go ahead and get the mass of this, and we're going to record that in our data table. So it looks like we have 45.183 grams for the evaporating dish. And I'll record that in my data table. Now to this dish, we're going to add some of our sodium bicarbonate. And that looks pretty good. And record the mass of that, which is 49.881 grams. So we're going to be using a Bunsen burner to heat here. Nothing really fancy about a Bunsen burner. There's an inlet for the gas, and then we have a little valve that controls the amount of gas that enters the Bunsen burner, and we have a little valve here that controls the amount of air that gets pulled in to complete the combustion. So it's a very simple device. It's just a tube that allows the natural gas to come up through, mix with oxygen, and burn. So that's how we're going to heat that, is with this Bunsen burner. So I'm going to transfer our dish with the powder to the ring stand. I'm going to gently heat the dish initially to let it warm up. Then I'm going to blast it a little more to really let that heat get to it and start the decomposition. So to light a burner, we're simply going to turn on the gas. Hear it hissing. Use this little sparker. We squeeze it, we get some sparks, and boom. You can hear it roaring a little bit. That tells me that the gas is coming a little bit too fast. So what I'm going to do is I can slow down the amount of gas here, and if you look real closely and get the camera, you'll notice that little purple flame there. That little cone is the hottest part of this flame. So we really want to get that part directly on what we're going to heat. So we're going to control that by raising or lowering our ring stand to bring the dish into the heat. Right now I'm just sort of warming it up so it doesn't crack. So after heating for a few minutes under low heat, it's time to turn up the heat. I'm going to lower carefully. Lower the evaporating dish into the hot part of the flame, and I'm going to let this continue for about 10 minutes or so. So we can see that it's getting nice and warm, the underside. Oh yeah, that's starting to cook nicely. So we're about done heating. It's been about 10 minutes, and everything looks good. What we're going to do to shut the burner off is simply come over, close the valve off, and the gas stops. Very simple, huh? So now we are going to just let it cool down for a little bit and then get the mass. Ideally right now we'd want to place it in a desiccator. A desiccator is a jar that actually has some material in it that absorbs water vapor. That would probably be a great idea to use right now, but I don't think we're going to have too much water recombining with this right now. Anyway, so we'll just let it cool down and get our final mass. Okay, looks like it has cooled down plenty. So what we're going to do here is we're just going to take our dish, transfer it to our balance, and let's see what we got here now. 48.101 grams. Yeah, it looks like we have a weight loss there. So now that we're finished, we can take that data and determine what was the percent mass lost in this reaction. So good luck with this, and I will see you when I see you.